Next one. So in this particular problem, I know the square root of 100 is 10. The negative just means there's an I. Notice how there's also a 4i, so 10i and 4i kind of acts like a variable, like an x kind of thing. Put them together, that's a total of 14 i's. When we write down complex numbers in the very beginning of this lesson, we talked about that you're supposed to write them as a plus bi. Or in other words, what you're doing is you're writing the real part first, and then you're writing the imaginary second. So get into that habit. So even though I had 14i coming first, I'm going to start putting everything in this a plus bi format, because on the exam that comes up for this unit, they tell you to put it that way. So you want to get in that habit. Real first, imaginary second. In problem number 7, I want you to see two things. First of all, I want you to see my checkbook, otherwise known as real. Good job. Oh. And on the right side, the other part of my checkbook. Gotcha. Real, real. How do I know they're real? No I. So on the left, the a plus 2 is equal to, on the right, the 6. Which means my a has to be 4. Da-da-da-da. And then the other part here that we have, of course, is my wife's checkbook. Or in other words, the imaginary part on the left side is equal to the imaginary part on the right side. So the b has to be 13. Good, somebody didn't say 7. Oh. 13 is correct. One of my favorite teaching tools is this.
Your shirt?
Dramatic effect.
No. Oh.
See if you can figure this out. Gray, what happened? Your name's not Gray. Distributed. Good job. Don't worry, I'll be calling on you sometime.
Okay, maybe.
Tristan, D. What do I do in the next one?
Distribute.
Better word.
Awful. Foil.
Foil. Or awful. Take your pick. Ready, set, go.
1. There's no negative. No. Wait, what? 1 substitute. You know how like being foil? No, you know how like 15 versus 4. How did you figure that out? Oh God! That's why I swear it's a little 4.
Oh, you guys. Tell me about I squared.
Negative 1.
Negative 1! No, I'll yell if I want to. You don't like it? Get out.
What?
Chicken butt. I squared is negative 1. And since we have negative 1 being multiplied by negative 4, that's the same as 4. 4 and 15 is 19. That number, were these two numbers put together. And then the 12i and the 5i is 7i. Olivia.
Oh.
In letter C, I notice that there's a binomial squared. That means I can use the Joachim method.
Yeah.
Square the first thing. Square the last thing. Multiply everything together. Now, if you don't remember the Joachim rule, it's not a problem. The only thing you have to remember then, of course, is that you are actually taking the two parentheses 1 plus 7i and then multiplying it by itself, which means you'd have to FOIL instead. So you can either FOIL or you can use my rule. Take your pick, it doesn't really matter to me.
Would be negative 49.
So then the answer, of course, is negative 48 plus 14i. Because remember, I squared is...
I squared is negative 1.
I squared is, indeed, negative 1. So that's really negative 49 plus 1, which is negative 48. So in part D, there's something kind of strange. And I want to point something out after I get done foiling this out. So let's look and see what happens when we FOIL. 4 times 4, 16. 4 times minus 5i is minus 20i. 5i times 4 is positive 20i. And negative 5i times positive 5i is negative 25i squared. Hopefully you notice that the middle two things, or in other words the I things, not the I squared, but the I things, go away. So I really have 16 minus 25i squared. But we know that I squared is really like negative 1. So instead of being negative 25, this is really positive 25. Or in other words, my answer is 41. What's strange about that? There are no i's. There are no imaginary numbers involved. This will happen every single time you multiply a binomial by its complex conjugate. Look at the first parentheses, 4 and a 5i. Look at the second parentheses, 4 and a 5i. Exactly the same, except the signs in the middle. One's positive, one's negative. Those are called conjugates of each other. Or in other words, they look exactly the same, except the sign in the middle is different. Every time that you multiply something that's a binomial by its complex conjugate, you will end up with a number, a scalar, a constant. There will be no imaginary numbers. It's a very powerful tool, actually. There is a shortcut to that. Look at the first number, 4. Square it. Look at the second number, 5. Square it. Add them up, and that's always the answer. In this last group, we just got done talking about complex conjugates. And you remember how a while back we did something like 3 divided by the square root of 2. And in this class I told you that you always have to simplify. And is that simplified?
Yeah.
No. It's not. Do you know why it's not simplified?
There's a square root.
There's a square root in the denominator. You're not allowed to have that. And so what you would have to do is you'd have to multiply the top and the bottom by that square root, and then you get 3 square root of 2 all over 2. Because square root of 2 times square root of 2 is square root of 4, and the square root of 4 is 2. That's called rationalizing the denominator. Imaginary things work the same. You are not allowed to have imaginary numbers in the denominator of a fraction. So you have to get rid of them. The way that you get rid of them is you multiply top and bottom of the fraction by the complex conjugate of the denominator. Those are a lot of words. Me, I don't know about you guys, but me, I'm a visual learner, bless you. So I'm going to show you what that means. In the first example, what that means is that I'm going to multiply the top and the bottom by 1 plus I. The reason I'm multiplying by 1 plus I is it is the complex conjugate of the denominator. Multiply the top and the bottom by the complex conjugate of the denominator. Okay, so in the part A for number 3, 2 times 1 is 2, and 2 times I is 2I. Using the Joachim shortcut on the bottom, I need to look at the two numbers. What's the first number? 1. So I have 1 squared, because you squared it. Plus, what's the second number? What's the second number?
1.
What's the coefficient of I? 1. 1. Negative 1 or 1. Take your pick. Square either 1 and you get 1. Doesn't matter whether you squared positive 1 or negative 1. It's going to be a 1. So really what's happening is I have 2 plus 2I all over 2. Now this is not in the A plus BI format, by the way. If I want to put it in that format, what I need to do is I need to divide those two things and divide those two things because it's separated by a plus on the top and there's only one thing on the bottom, trending down. And so really I get 2 over 2, which is 1, and 2I over 2, which is 1I, and then there's a plus sign in between, and this is my final answer, 1 plus I. So on the second one, I also have to do the complex conjugate as well, 4 minus 3I top and bottom, because I have to match the bottom but have a different sign. Foiling the top will be 2 times 4, which is 8, 2 times minus 3I, which is minus 6I, minus I times 4, minus 4I, minus I times minus 3I, which is positive 3I squared. In the denominator, if I use the Joachim rule, then I look at the first number, which was 4, and I square it. I look at the second number, which was a 3, and I square it. And I'm going to be adding these numbers together. Again, you can FOIL. I'm skipping that. In the numerator, I see that I have a negative 6i and a negative 4i. That's a total of negative 10i. And that came from the negative 6i and the negative 4i. But the other part is the 8 and the 3i squared. We know that I squared is the same as negative 1, which means that positive 3 now becomes negative 3. Negative 3 and 8 is really the same as positive 5. On the bottom, I have 16 plus 9, which is the same as 25. If I simplify that, 5 over 25 is the same as 1/5. And 10 over 25 is the same as 2/5. Don't forget your I, and don't forget the negative sign. The reason I write it that way is because that is in the complex form that they wanted, which they said was supposed to be A plus BI.
Don't give that away.